So I just wanted to do a quick video here. It's, I guess we can call it a back to basics video. It's not really fully a back to basics video, but it'll be in that playlist anyway. So what I have here is my supercapacitor bank with a little voltmeter attached to it, and it's partially charged because this voltmeter needs a little bit of power to run. So we've already got it at about 3 volts, which is about the minimum this thing will turn on. And then I've got this guy over here that's set up for current reading. So we're currently set to amps, we're set to the high current setting. And then I've got my power supply off screen here set to 15 volts. And it's coming in through the multimeter and then back into the capacitor bank, and then this is the end of the power supply. So what I wanted to demonstrate here today is the way that capacitors can kind of act. Let's see if I can get rid of that weird little glary bit. There we go. Oh, no, that made it worse. That's good enough. Anyway, capacitors kind of act like a resistor when they're in series. Because as they come to full charge, they start, the current that they permit to pass through them starts to drop down towards zero. The voltage goes up, the current drops to zero. So their resistance, or their equivalent series resistance, starts to go up and it climbs towards infinity. And we can demonstrate that here, and I wish I had a 12-volt bulb because that would actually really very thoroughly demonstrate. I need a 12-volt tungsten. I don't have any on me. Anyway, so basically what we'll see is the current on this will drop as the voltage climbs here. The voltage drop across the capacitors increases towards our supply voltage. As a result, its resistance goes way up and the current will go down. So let's go ahead and observe that. It's going to happen very quickly because I don't have any resistors in line here. So voltage, current, and go. So we start off at about 1 amp, which is a little hotter than I'd like to charge these caps, but that's okay because it's going to drop very quickly, as you can see. We're already up to 7 volts, 8 volts, dropping really quickly here, climbing really quickly here, working our way towards the 15 that I have the power supply set to. We're already at 11 now. The amperage is dropping even faster now. This is actually going to accelerate, and this is going to slow down, which is another interesting little quirk of the way these capacitors work. So we're up to 14 volts here. We're already down to 100 milliamps. That dropped so fast in the last couple of seconds. You know, reaching 14.5, continuing to drop down to 70 milliamps, 60 milliamps, 50 milliamps, 40 milliamps. Starting to slow down now because we're going to start seeing the current consumption of this thing figured into the readings here. We're down to 30 milliamps, still slowing down. We're basically at the max voltage of the power supply currently. I've got these 2 Schottky diodes. They're going to be dropping about 0.3, 0.4 volts. Or maybe it's 0.1 volt on a Schottky. I don't remember. Very low voltage drop across a Schottky diode. But they'll prevent a pulse of current from going back into my power supply if I don't disconnect this properly. Yeah, we're down to 21 milliamps, 20 milliamps, getting there. 14.6 volts here. The power supply reads 15.18, so we can actually go, 15.2 minus 14.6 is going to be 60 millivolts, which is 30 millivolts per Schottky diode. So 0.3, that was correct, that's what I said. Continuing to drop the amperage here, and it's probably gonna grind to a halt here, probably around 10 or 15 milliamps. I don't know what the current consumption of these little displays is. I can actually find out. Go in here and find the other displays, which should be in here somewhere. I'm gonna bang it around in the background. There we go. Oh, no, that's the lithium battery display. That won't do any good. Another lithium battery display still won't do any good. Where the, there, no, that's a button. All this random, non-related flotsam inside my diodes box. Weird. Continuing to bang around. Oh, hey, here's one. I really need to organize this place. Anyway, we'll take a look at that in a second. Anyway, so we're at 14.6 volts. And nothing's changing, which gives me the impression that this pulls about 14 milliamps when it's running. But let's go ahead and find out. So I'm going to disconnect the super cap here. We're going to put that off to the side and just kind of let it discharge itself through the voltmeter display there. So let's go ahead and connect this second voltmeter that I just found right across, and we'll find out what the current consumption of the voltmeter is. Well, that reading says about 6 milliamps. Let's change over to the milliamps reading and see if we can get something a little more accurate. So, yeah, about 6.5 milliamps. I guess that's not too bad. That's probably mostly in the LEDs rather than the circuitry. I suppose I could desolder one of the either the cathode or the anode, whichever is the common pole on that one, and see what just the circuitry pulls. But 6 milliamps is pretty small. Anyway, so a little bit off topic there at the end, but just wanted to demonstrate how capacitors will act as a resistor when in a DC series circuit, and that is also why you can use capacitors in capacitive droppers for LED power supplies or other low complexity circuits if you just want to pull voltage from the mains and have a bit of current control, because resistors will generate a great deal of heat as they are dissipating current, or dissipating voltage and current. But a capacitor doesn't generate heat, it just stops letting current flow through it once it reaches its charge. So you can use a capacitor in an AC circuit to control how much current goes through each side of the waveform. And we'll explore that later. I'm focusing more on DC circuits at the moment. So yeah, hopefully that answered some questions you might have about capacitors. If you have any more about what I've demonstrated here, feel free to ask them in the comments below. If you haven't already, consider clicking here to subscribe. Right over here is a video that YouTube will pick from the channel that thinks you might enjoy. Right here will be the Back to Basics playlist, and right here will be a link to Patreon that you can use to help support the financial needs of my channel. So thanks so much for watching. Sorry for the long hiatus, and we'll see you next time. Bye-bye.